All right, we're on the second page of the study guide. Questions 9 through 12, really similar to the ones we just did. So what type of transformation is this? Well, we should recognize that this is a rotation. We know we need distance we need degree and direction. So it is a 90-degree rotation. And the question is what direction? So if I'm mapping my original triangle, XGN, onto the new triangle, if I'm going 90 degrees, I'm going this direction, which is counterclockwise. All right, the rest of this is kind of similar to what we've been doing, but it's a little harder in this one because we have to use the Pythagorean theorem for all three of these side lengths. So to find the length of XG, because it's not a horizontal or vertical, I can make a little 1-by-1 right triangle. And for XG, my A and B essentially, because again, we're using the Pythagorean theorem, a squared plus b squared equals c squared. So that's going to be 1 squared plus 1 squared equals c squared. 1 squared is 1, not the number 2. So we get 2 equals c squared. Take the square root of both sides. We get the square root of 2 for that. So that's the square root of 2. For GN, it's 2 by 2. So plug that into the Pythagorean theorem. 2 squared plus 2 squared is c squared, which is 4 plus 4. And that's going to be 8. So I can take the square root of both sides. The square root of 8 simplifies to 2 root 2, if we remember that from algebra. If you don't, it's no big deal. You can always write it as a decimal there. Honestly, I will take the square root of 8. And then lastly, the length of side NX or XN. Again, I have to use the Pythagorean theorem. So my legs are 1 and 3, I think, right? 1, 2, 3 units. So for XN or NX, I guess it says NX over there, we're going to do 1 squared plus 3 squared is our hypotenuse, which is the side length we're looking for. So that's 1 plus 9. Square that, add them, and take the square root. So we get the square root of 10 for C. And that one can't be simplified, but you could write that as a decimal. All right, so those are our lengths. Anytime it's not a vertical or horizontal, we have to use the Pythagorean theorem. So now identify the corresponding parts. Well, side AB corresponds with the side that is also going to be like 2 by 2 if we plug it into the Pythagorean theorem. So side AB corresponds with side NG, because remember, it's a rotation. Side BC, the shortest side, corresponds with GX, and that leaves side XN to correspond with CA. So this one's a little tougher. Complete the statement. So XGN is going to be congruent to CBA. So triangle CBA. All right, so that's the last one. We want to remember all of our rotations and reflections from our last unit for this. Transformations to be general. So do translations produce congruent figures, and explain? So the answer to this is yes. All translations are congruent. So to explain, we could say translations move all points the same distance and direction. And that's going to imply congruence. Another thing you could say here is that a translation is an isometry. So translations are isometries, which we said in our last unit, all isometries are congruent, produce congruent figures. All right, do rotations produce congruent figures? Well, going back, like this is really asking us about the questions we were just doing. we got congruent triangles in 9 through 12 when one triangle was rotated. So the answer again here is yes, rotations produce congruent figures. And to explain that, we could say rotations change the orientation and position or location of a shape, but not its size. All right, do dilations produce congruent figures? So this should jump out to us as a no. Dilations produce similar figures. So dilations produce similar figures. And that's like, for example, when we did our AAA triangle constructions, we got similar triangles. So similar figures, and that's based on their scale factor. So they're larger or smaller. And then lastly, do reflections produce congruent figures? This is a yes again. Reflections change the orientation of a figure or a shape, but not its size. All right, that's it for the second page.